Olá pessoal, sejam bem-vindos a mais uma live do IMA Experience, essa iniciativa que busca aí trazer temas relacionados à digitalização industrial. E hoje a gente vai trazer um tema bem importante aqui, relacionado a uma tecnologia nova, o i-UNS, para otimizar aí a estratégia de controle industrial. A gente vai receber alguns convidados especiais aqui. Eu queria chamar o Heitor ao palco, Daniel também. Daniel... Hello. O Daniel Goldeband, que é da iFlow, e o Heitor Marson, que é da Build Our Indus, vieram falar aqui um pouquinho com a gente. Falar um pouco sobre o i-UNS. Para você que está ouvindo aí o nosso bate-papo, deixe suas mensagens no chat, onde você estiver. Esse bate-papo vai ser realizado em inglês. O Heitor aí vai nos ajudar aqui a intermediar e fazer também a introdução, condena os questionamentos que vocês tiverem, para que a gente possa abordar sobre esse tema. Se tiverem alguma dúvida, podem digitar aí no chat, que a gente vai interagindo aqui com o Daniel. E também, se vocês tiverem com alguma dificuldade, podem ir lá no YouTube e ativar lá o Closed Caption, para ir conseguindo acompanhar aqui também. Então, obrigado aí, Heitor. Thank you, Daniel. Join us. Fica à vontade aí, Heitor, para conduzir o bate-papo.
Beleza, Marcos. Obrigado, pessoal. Obrigado, audiência aí. Apenas para contextualizar, para quem acompanha já o IMA, tem participado dos nossos eventos, tem participado das lives. Essa é uma live, é um conteúdo, é uma Masterclass que ela vai dar continuidade no que a gente tem trazido para o mercado brasileiro, no que a gente tem defendido para o mercado brasileiro, que para o mercado, para a temática industrial, de fato, o INS é a melhor solução para acelerar e continuar trazendo soluções para os times industriais, para os times de automação, otimizarem essa convergência TI-TO, de fato alçarem um novo nível de como utilizar, monitorar, controlar os dados de processo. A gente nessa nossa missão aqui, enquanto Build, enquanto IMA, juntamente com o Bioenergy Hub, é trazer soluções para que os departamentos industriais fiquem cada vez mais autônomos, dos departamentos de tecnologia tenham cada vez mais autonomia para que esse dado que é gerado no processo industrial seja utilizado e otimizado com muito mais independência, e tirando aí TI como ponto de gargalo das gestões de informações corporativas, que a gente tem visto que TI não tem dado mais conta de ficar controlando tudo, represando tudo. Então, a gente reforça aqui o nosso posicionamento de escolher por UNS como a melhor solução aí de trazer a tua indústria para um próximo nível em como a informação está sendo utilizada. Tá? A gente agradece muito aqui o Daniel da iFlow. A iFlow já é parceiro da Build aí há mais de um ano. A gente tem reforçado, atacando aí o mercado industrial, todos o potencial que a iFlow já tem entregado para os clientes ao redor do mundo, e a gente tem feito o papel aqui de trazê-los para o mercado brasileiro. Após essa call, qualquer interesse de vocês em aprofundar, seja com uma reunião, uma sessão mais técnica, tanto eu quanto o Daniel e o Marcos estamos à disposição para continuar evoluindo na direção do que a gente vai falar hoje. Hoje nós vamos falar do UNS aplicado à temática de controle industrial. Então, dadas infinitas possibilidades e benefícios que uma plataforma de UNS pode trazer, hoje a gente vai enfocar na questão de controle de processo industrial. Ok? Eu vou mudar agora para o inglês para fazer a apresentação do Daniel e passar a palavra para ele. So, Daniel, thanks again for your time, for your availability. Thank you for all the effort and energy that you are putting together with us in the Brazilian market. It's a pleasure to us work together with you and to explore the potential of iFlow and i-UNS to the Brazilian industrial market. So thanks again. It's a huge pleasure and an honor to work with you. So I transfer the microphone to you right now. Anything you need, please ask my help or Marcus, but now it's you. Thanks again.
Thank you, Heitor. Always a pleasure working with you as well. And thanks for having me. I'll try to share my screen. Can you please, Heitor, if you see my screen, could you give a thumbs up?
Yes.
Perfect. All right, so let's jump in. So again, thanks for having me, Heitor. Great working with you, and also targeting the Brazilian market, which is for sure a very interesting market, also for the Unified Namespace and for the topic that we are discussing today. So how do you basically control factories using the unified namespace, or how does a strategy evolve using the unified namespace. In the next minute, I will talk about connecting factories at scale using that unified namespace architecture. So I will introduce very quickly into the concept again with a couple of slides, and then shifting to a demo that gives a glimpse on how this changes, so the unified namespace approach changes the way how we can control factories today. This session is not meant to be complete because there's not enough time to cover it all, right? So I won't do a deep dive in the concept, I won't do a deep dive in the demo of the iFlow platform, and I won't be able to cover the entire factory control strategy approach. However, it's meant to be a glimpse of all of it, and if there's any interest to see the platform or the concept, or to discuss factory control strategies in more detail and how it evolves with the unified namespace, always happy to jump on a call. So before that, let me introduce myself a little bit. So I'm iFlow. I'm Daniel, one of the directors of iFlow, and I'm responsible for sales and partnerships, for example, with BYI in the Brazilian market. Before joining iFlow, I actually was working for big manufacturing companies already. So you all know, for example, Bosch, like 300 factories around the globe, right? I was responsible within a business unit of iFlow to scale digital initiatives within those factories. So to go from transparency, predictability to self-optimizing factories. And that's where actually I spent my whole career. And I would call myself an Industry 4.0 enthusiast, having done projects on the ground, right? So implementing collaborative robots, AGVs, up to applying analytics on top of factory data. So basically a big, like various use cases implemented already in real factories. And with that, I will keep it on my person. A little bit context on iFlow, because I won't talk much about the company itself. So iFlow, we're an industrial software company based in southern Germany, and our technology, or based on our technologies, companies like end customers, manufacturing companies, but also partners like BYI can build unified namespace architectures in their infrastructures. We have customers worldwide, including renowned Fortune 500 companies in the US, South America, Asia, and obviously also in Europe, and especially in the DACH region, so the German-speaking region. With that, I will keep it about the introduction part, and I will shift towards the concept of the unified namespace. And I want to keep that short, but in the end, it's always helpful to get a little bit of perspective and how the unified namespace actually helps to create smart factories and to create Industry 4.0 at the end. We all know that smart factory is not a one-time achievement, right? It's an ongoing journey, and we can actually divide that journey into 5 steps. So first, lean. Lean is always the foundation. If you do not have lean processes in place, you won't be able to climb the ladder. Step 2, connect your factories. So by fully connecting your factory systems, for example, machines, ERP, MES, SCADA, whatever you need, you make sure that you create interoperability between those systems. So basically to create interoperability between IT and OT. And that's exactly where the unified namespace come in. Step 3, create a transparent factory. So that means understanding why something happens, for example, by implementing use cases like OEE, right? So OEE analysis to understand why actually a machine downtime happens. Step 4, achieve predictability. So that means at this stage, you actually use the data as a powerful tool and resource for forecasting. So by that, you can prevent issues before they occur, such as downtimes. And last but not least, adaptability. That is step 5. That means actions and decisions are actually executed dynamically without human intervention. So for example, adjust production parameters by knowing or optimizing output and ensuring maximum performance. I will touch it a little bit in my demo later on, so stay tuned. when we actually check, or when we look into surveys, so where actually does the current industry is, or where's the current industry stuck, it's actually step 2. So the connectivity step. Actually, the reality and the truth is 81% is stuck in that step. So what does it mean? Actually, it means that over 80% is not able to climb step 3, step 4, step 5, right? And it's a simple math, because what happened in the past decades, customers of ours, they created those point-to-point integrations, right? So a customer of ours typically has 1,000 systems or more. They operate dozens of factories. And if you connect each system one by one, point to point, it is getting very complex very soon. Because if you want to connect each system individually together, so connecting your PLCs with your MES, connecting your PLCs together, also with your ERP, that would mean, if you would do it point to point, you would need to create and manage 500,000 individual connections and integrations. So simple math, just not possible. And exactly that's where the unified namespace comes into play, right? So that's where the strength of the unified namespace plays into or comes into account. So let's introduce it a little bit more detail. What does it mean, a unified namespace? Unified namespace is first and foremost a single source of truth for factory data. So every system is connected into that common namespace. So that means every PLC, MES, ERP, your SCADA, your QMS, so quality system, or other systems you have in your landscape, will publish data into that common namespace, and all other systems can consume that data from that single source of truth. No more individual integrations. And with that, you actually decrease dramatically the integration complexity. So you go away from point-to-point integration to a publish once, distribute everywhere architecture. That means you connect a system once, right, into that common namespace, and from there, any system can directly consume that data. So coming back to the customer I was talking with, that 1,000 systems in one factory, that means that instead of building 500,000 individual integrations, you only need 1,000 integrations. And using the unified namespace actually means at the end that you create an architectural foundation for all your digital initiatives, right? Step 3, step 4, and step 5 to a smart factory. And I will show you now how that actually looks like. So how does that common namespace look like? So let me switch to another screen. So let me pull up a MQTT Explorer, which is basically a client that lets you have a look into a broker. So in our case, we use MQTT brokers to create that common namespace. And an MQTT broker has clients, right, like systems, PLCs, or ERP or ME systems that publish data into the namespace, but also consume data out of that namespace. That MQTT client I'm using is MQTT Explorer, and I can just browse through the data. So browse through the single source of truth of that demo factory. And once I browse that namespace, you see that that namespace is actually organized the same way you organize, for example, your SharePoint using your company, or using a SharePoint for organizing your company's data. So you have folders, right? So you create subfolders in a SharePoint, and then subfolders to organize your company data and to let anyone who wants to get access to the data directly find the data and have the data at his fingertips. The same thing applies to the MQTT namespace, right? So we have those folders, subfolders, and subfolders, which in MQTT terms are called MQTT topics, that allows you to organize the factory data. So in that case, we have a customer that runs three factories around the globe, and within one factory, they operate 3 different production areas. Inside one production area, they again operate different lines, and so on and so forth. We also can go down to a cell and actually have a look into the different payloads, so the different data that is sent by each PLC in this case. So for example, that milling machine sends telemetry data, it sends some metadata for that machine. identifying the machine and the vendor and so on, some maintenance-related data, KPIs of that machine, but also production order-related data. The same thing applies for IT, right? So not only PLCs publish their data, but also IT. For example, the ERP, so could be SAP. In this case, for example, order-related data, such as the production order, when was the scheduled end time or the scheduled start time of a production, and so production order, and so on and so forth. So basically, all systems in a landscape publish data into that common ground, so that common data space, which is based on MQTT. And with that, you create that single source of truth that enables you to consume directly data from any system you want. With that, I will keep it for the concept part. So basically, this is the unified namespace and how it looks like. And we will now dive deeper into how you basically create that unified namespace or that MQTT namespace with the iFlow platform. So I will switch back to my presentation and jump into the iFlow platform. So a unified namespace is not a single technology, right? It's not one MQTT broker or one Kafka broker or anything else. It is basically a distributed architecture that is distributed across your factories and across regions. And our customers build a unified namespace based on the three modules that you see on this slide. So first, the iFlow Edge, so starting from the bottom, the iFlow Edge, which integrates, harmonizes, and publishes the data from different sources into the unified namespace. Second, the broker. The broker holds the namespace and the current state of the truth. And last but not least, the iFlow Hub, that allows you to manage, monitor, and govern your UNS ecosystem. And what that means, I will show you now, jumping into the iFlow platform. And what we will see now is the iFlow Hub, which is actually the only software module of iFlow that comes with a user interface. And as I said, that iFlow Hub allows you to manage, monitor, and govern your unified namespace. So let's jump into it. And you see my browser. And this browser now allows you to connect to the iFlow platform, in this case, the iFlow Hub. And once I log in, I will see some metrics of my unified namespace. I won't go into the bits and bytes of the platform. I will just show you in a very quick demo how the unified namespace is built in principle and how customers use that iFlow Hub to create that MQTT namespace that you saw. The first task is always to create the edges, right? So you have seen edges before on the slide. Edges are basically the runtimes where all the logic that you create in the hub runs locally, right? Because for security reasons, you want to run every logic that you create inside the hub, internally, inside your factories, inside critical OT networks and environments. And here on that edge page, you can see 3 demo edges that I created earlier. So for example, in my factory in Prague, there is one edge instance installed at line 1, or in my factory in Munich. I could now add more edges here, or I could simply jump into one edge and see some metadata about that edge. So first task is always to create edges, so to create that local runtimes that actually at the end run all the connections, all the integration, the harmonization logic that we will implement now. Second step is you connect to your systems. So how do you connect to the systems like PLCs, like MES or SAP, in order to pull out the data and send it to the MQTT namespace? That's what you do in the connections, in the connection page. Here you see all connections that have been established into the unified namespace, be it OT or be it your IT systems. For example, your different brokers, your OPCOA servers in your factories, your SAP, your cloud systems like AWS and so on. So what I do is I create a connection. I will call it IMA demo. And now you can basically choose from our internal plugins. So for example, most common databases that we support, like time series, like SQL databases, most common machines and devices, MES, IoT platforms like AWS I mentioned, or Azure Event Hub. So what I do is, what you do once you connect to a system is you basically choose your driver and then you configure the driver. So for example, I will just quickly configure that. And now I have created a configuration in the iFlow Hub. And now I want to instantiate that connection instance into one of my iFlow edges that I installed in the field. So again, I can now deploy this connection into the different edges that I created earlier. So for example, into the factory edge that is running at line 1 in Prague. So I deploy it, and what will happen in the background is it will try to deploy that configuration, which will not be working because it was just a dummy configuration, but I think you get the idea of it. So let's jump into one existing one. So for example, here I have a running connection into my broker in Prague, and I have different instances of that connection running in the different edge instances locally in my factories. That was step 1, connecting your systems, right? Not only your PLCs, but also your IT systems like SAP or others. Second step is to model your data coming out of your PLCs, because most of the time OT data is not standardized. That's where models and assets come into play. I won't go into the bits and bytes. If you have issues with that, let me know. I will skip that part just for time reasons. But if you are interested in that part, let me know. We can go into the bits and bytes, how you can model data coming out of your OT based on common standards like OPC-UA companions or others. And then with the flows, do the integration into the MQTT namespace. And that's what is the last step, so to say. So how does the data flow into the namespace once you have connected and modeled the data? That's what you do with flows. So I could start actually creating a new flow. I will do IMA demo flow, and then you could start creating a flow from scratch. So for example, starting a data flow based on events, right? So based on a machine event or cyclic events, like for example, every 500 milliseconds, I want to trigger that flow. And I want to actually get data out of a modeled asset that I created. So for example, my milling machine, and I want to send that data directly into my MQTT namespace. And you see that I have so-called processors in iFlow, where I can basically trigger input data into the flow, create logic around the flow, for example, based on my own programming or based on simple logic processors like filters and so on. And I can also use processors to output data, such as, for example, output data into the MQTT namespace, or send data to, for example, AWS, or send data to my SAP instance. So what would happen is I would basically now choose my MQTT broker. I would choose the topic. So going back to my broker, you see that the organization part, right, of my data, this is called MQTT topics. So I could now specify a topic where I want to publish that data to. So for example, a topic 123, and then send the data, either the entire payload or single parameters, into that topic. And if I click save, I create a new flow version and a new flow logic. I could now choose again the edge where I want to run that logic and deploy that logic directly onto that edge instance. So that is basically how you then integrate data into the namespace and how you create that common ground for your IT/OT integration. With that, I will keep it with the demo. It was very short and not touching everything. Obviously, there's way more into it. For example, security, for example, talking about certificates, talking about user and role management. There's much more, right, to explore. But with that, I will keep it here to keep it, very simple for everyone to follow. In case you're interested to see more, let me know. We can always do a deep dive into the bits and bytes of the platform. Going back to my slides. So basically what you saw now is the 3 different modules, right, and how they interact, right? So how we use iFlow Hub to create those resources, to deploy those resources, and then to publish the data into the broker to make it shareable across the entire network. Now the question becomes, how does this transfer to control strategies, right? So what does this have to do with controlling factories, controlling PLCs, and so on? And that's what I want to show you now. So basically, I want to use a second to again discuss how the control strategy actually evolved over time, right? So from lean processes up to self-optimizing factories, how can we adapt control strategies in those steps, and also where does the unified namespace help you? And I said it before, right? So control strategy is a very big topic. I actually saw a LinkedIn post from Jeff Winter. I don't know if you know Jeff Winter. He's a very famous guy in Industry 4.0, and he actually published a very cool video or GIF this morning. And so production control involves so many different systems, right? And so it involves supplier information, it involves custom information, it involves order information, it involves so many things and so many different people as well. So too much to cover it in a couple of minutes talk. I will use very simple examples, very also dramatically simplified examples to just give you a glimpse of how you can use the unified namespace and how customers of ours use the unified namespace and iFlow to optimize production control, knowing that factory control and production control is a way broader field. I will make it very simple to make it a little bit simpler to digest. So going back, let's see how the control strategy actually evolves using the unified namespace. So starting with lean, right? So how we started controlling our factories is basically controlling PLCs individually, right? Isolated machine control. And then operators used Excel sheets, for example, or paper checklists for production tracking. There was no MES, there was no SCADA, there was no ERP connection. And actually the SAP only received end of shift papers, right, and reports. So someone manually typed in end of shift reports so that at some point my SAP knew that the order, for example, was produced. That is also something you can do with iFlow. So you can do actually isolated machine control. That's actually something customers are doing. I will show you how that works in iFlow real quick. So going back to my iFlow system, I will use a blueprint because also iFlow offers a couple of blueprints, which are customer example use cases. And I will show you one data flow that you can use to control individual machines. And that is something done by customers as well. So in this case, this data flow consumes TCP data. So TCP packets are sent from the PLC into the iFlow edge. And then iFlow parses the buffer to make the data understandable, filters the data, buffers the data again, and then sends the data back into the control. So very simple flow. Most of the time, it's a little bit more complicated, right? So some customers have traceability databases, for example, and based on TCP packets, they will send data into, I do not have a running SQL database here, but they send data into the traceability database to trigger, for example, stored procedures, and the response then is sent back to the machines. So, for example, based on plain TCP again, or sent back to Siemens controllers using the S7 write processor. So that's how you could use, and that's also done by our customers, how you can use iFlow to basically connect individual machines to individual systems of yours. But that's not where the magic happens of using the unified namespace. That's coming later. I will show you now. Step 2, creating islands of automation, so to say. So what happened in the past, right? So now, once you had isolated machine controls that you can do with iFlow systems or others, now you can put MES or SCADA on top to not only control individual machines, but to control entire lines, right? So line level control. That's what you can introduce using systems like SCADA or MES. However, back in the days, and still today, for a lot of our customers, they are still disconnected from higher level systems like ERP, for example, talking about SAP. So they still have limited connectivity to higher levels. I make one example. So a customer of ours, they actually had an MES system, and that was disconnected from ERP. That was very manual and error prone because the data from MES had to be synced manually to higher systems like ERP. So in that case, they did manual material backflush in SAP after the order had been confirmed and had been finished in the MES system. And sometimes it was not in time. So the confirmation of the material backflush was not in time. So that meant the next production line could not start producing. So again, line downtime is something you want to avoid. And that's where the unified namespace comes in, right? So you can use the data from your unified namespace to share it also to your ERP system. And I will show you how that works. So let's pull up the demo again. So you see again the unified namespace, right? And the different systems publishing data into the namespace. For example, in this case, the milling machine, Mazak, publishes data using the iFlow edge that has execution and material backflush information for ERP. And we can now consume that data to make the backflush confirmation inside SAP using, again, the iFlow hub. So I will share my screen again, go to the flow section, and pull up a very simple flow that I created just before the session, which subscribes to the data from my namespace, right? So that subscribes to that execution data. So using an MQTT subscribe processor. So you see here the topic subscribing to the execution topic, then filtering the data. So if there is no actual end time, meaning the production order was not yet confirmed by the machine, then the data flow won't continue. If it is confirmed, the data flow will enrich the data with the bill of material and send the entire data packet into the unified namespace again. and you could also send that data, for example, using an OData interface directly into your SAP, or using remote function calls to directly trigger material backflash confirmation inside SAP. So let me demo this real quick. So this flow is activated. Nothing happens because we see here that in this case, there is no actual end time, right? So the machine did not yet confirm the order, but let's demo that. So I will now send a trigger with a system you cannot see, but I have a back system where I can basically trigger the machine to send the actual end time. So real quick, you saw the end time tickling in, and you also saw that now the entire material data is now also published into the namespace. And as I said, you could also send that data now to SAP to make the backflash confirmation. So wrapping it up, you use basically local data coming from your PLCs, not only in your SCADA, not only in your MES, but now via the Unified Namespace, you're able to send that using iFlow also to other systems like SAP to directly automate processes like backflash confirmations. Other customers, they confirm production orders, or also they use obviously that data in the Unified Namespace to create dashboards like, unknown boards or so just visualizations of where my current state of my order is. Is it at production line 1? Which PLC processes which order? Are we in time with those orders, and so on and so forth. So consuming data out of that common namespace becomes very simple. Next step is going from a reactive to a predictive mode, right? So how do you use predictions or algorithms or your own AI trained models, you name it, to actually shift from reactive to a predictive control strategy? And that's also where you can use iFlow, and I will show you how you can use it. So going back to my flow section, I will just open up another flow. It is again highly simplified, but I think it is better to understand in a very short time how you can control your PLCs and your factory using a unified namespace. So what this flow does, it again consumes and subscribes data. In this case, it subscribes data from the telemetry topic. So jumping in back to the MQTT namespace, let's open up the telemetry topic that is consumed by that flow. And this shows now telemetry data that is sent by a PLC into the common namespace. And I want to now consume that data to, create a very simple anomaly detection and send alerts in case there's an anomaly detected to my maintenance team. So, and what you can see here is there are certain parameters sent by that machine. For example, the current feed rate, the current spindle speed, the spindle temperature, the machine override, and so on. So different telemetry data from my real-time process. And I can now consume that data using, again, iFlow, consuming the data out of that topic. And what I do is now I group the data. In this case, I want to group the data and the spindle temperature. So I just drag and drop the spindle temperature into the field here. And I define that I want to group it by 5 samples. And then I want to use an anomaly detection processor, which you can use in iFlow, and define it. So I again use the samples that are grouped in the grouping processor. I want to use a Z-score algorithm, and I define my threshold for the anomaly detection. And once an anomaly is detected, I want to republish that into the common namespace. So you see that the flow is activated, and I actually send that data back into my namespace. For example, in this case, into alerts and anomalies. Now you don't see any anomalies because there aren't any. But again, I can hopefully make that happen using this flow. So again, I activate that flow, and I hope that we will see some anomalies that are detected real soon. So once an anomaly will be detected, there will be a new topic created. So you saw a new topic got created, and you also see the anomaly value, in this case 70 degrees Celsius. So what that means is now you could use that data point to visualize that data point in your dashboards, or send it, for example, also using iFlow to your maintenance team, for example, using an MS Teams processor, and send the anomalies to the channel of your maintenance team. So the maintenance team will get alerted via MS Teams. You could also use databases to store and historize the anomalies, to do a retraining of your own models. Basically, you are very free. While this is very simple, you can also go a little bit more complex. So you could also use your own AI, your own trained AI models. You could deploy them next to the iFlow Edge in your factory in Prague at line 1. And you could use our AnyConnect service to connect your own trained AI model to do the anomaly detection for you, and then process the anomalies and the output of your model inside the flow again. So you go beyond this very simple Z-score algorithm. For simplicity reasons, I just use that now to showcase how it works in general. So now that we got from reactive to predictive, right? So we push alerts to our maintenance team. We can now go to self-optimizing factories. So we can use iFlow to send back the anomalies and to send back results of your different parameters that you set, your different analysis that you did, send back those values to the PLCs. So for example, to react on different anomalies, to adjust feed rates, to adjust temperature settings. So basically to fine-tune your PLC parameters based on results inside your flows. And that's something I want to show you real quick as well, how that works. So I can now use this flow not only to alert my team, but also to send back data to my PLCs. So for example, I will use OPC write, or you could, use a Siemens S7 write processor, but for simplicity reasons, I will now use an OPC write processor that writes back data and basically adjusts PLC parameters in real time based on the anomaly that was detected. So I will choose a connection, in this case, for example, my OPC server at line 3, and I will select the node that I want to adjust, for example, the feed override. And in case I detect any anomaly, I want to adjust the feed rate to 80%, right? So I will lower the feed rate just to give me more time to analyze my anomaly. So if I would now activate that flow, it would dynamically adjust my processors at my feed rate according to the anomalies that got detected. You can get, again, you can get way more complex. So you could also input dynamic adjustments and so on and so forth. But for simplicity reasons, we keep it with that. So in this case, sending back, reducing the feed rate from 100% to 80% feed rate. So meaning, now we not only predict, we also adjust production parameters based on anomalies that got detected. You can also use the Unified Namespace to do, as I said, your own model training. So what customers actually do is, I will jump back into the MQT namespace. What customers do is, they will consume data from, for example, different payloads and different data sets from IT and OT, just, for example, like the temperature I used or the feed rate I showed you, and then will correlate that data, for example, with the inspection result per part to see if there is a correlation between the two. And that is basically the magic of the Unified Namespace at the end, right? So if you created that common ground, that common understanding between your systems, you can consume the different data points and use the data points in any system you like. And that way you get way more faster in creating different use cases and put data-driven use cases on top of your factory data. And to wrap it up, I just want to show you this is done. So controlling of factories and PLCs is done by our customers. In this case, is one example, Hirschvogel Group. For those who do not know Hirschvogel is a leading manufacturer of steel and aluminum components. They're actually one of the leading automotive suppliers in the world. They have dozens or 8 production sites worldwide and 6,000 employees and a rough revenue of 1.5 billion. And they actually use iFlow and the iFlow ecosystem to do real-time production control. And by that, they increased the line output by reducing the inefficiencies I was talking about, right? So they use iFlow to create the flows, to create the namespace I showed you, to optimize production control, to reduce all the inefficiencies that are created by data silos in their different PLCs, in their different systems, MES, databases, and so on, by combining all the data and using combined data to reduce inefficiencies and to optimize production control. Not only that, obviously the Unified Namespace creates that foundation for digital transformation. So that means you can not only control factories and PLCs, but you can also use that data, for example, to create dashboards, to train your models, and so on and so forth. So basically that common ground, Unified Namespace, is that foundation for digital transformation. And with that, I stop talking. Again, thank you very much, BYI, for having me. In case you want to deep dive in anything, let's do it. I know it was very short in time. The concept only touched briefly. The demo, jumping around a little bit, but I just want to try to give you a glimpse of each individual element. In case you want to deep dive, just let me know. Talk to Heitor if you want to do a 30-day free trial and play around in the iFlow platform yourself. Heitor is always happy to coordinate if you're interested. Thank you.
Thank you, Daniel. An amazing session. I think your approach dividing the steps, the control strategy evolution was extremely clear and will help us a lot to approach that here with our clients. Personally, my opinion is that in Brazil, we are getting stuck in the step of breaking the silos. We are facing a huge political and internal cultural battle. Who is the owner of the data? But in the end of the day, is the industry, is the corporation. It's not one specific area. So I think my suggestion is that maybe in the next section, we can approach how to promote this breaking the silos, since we have IT managing this data in a not friendly way, but it's just my comment. Daniel, we received many questions here, great questions. I selected a few of them, maybe I put in an order here to make sense to us to try to approach it to conclude this session. The first one I choose in the hot topic that we are facing right now, it's about artificial intelligence. If you can talk more about since the client has implemented an i-UNS, how do you see this improving the artificial intelligence adoption internally in an industry? If you can go deeper, I saw that you mentioned during your presentation, but how can you defend UNS as a key player, an accelerator to artificial intelligence initiatives? We are seeing many companies trying to do artificial intelligence things, but in the end of the day, the data is being a huge problem, how to implement these initiatives. How do you see UNS in this scope?
Yes, it's actually a perfect fit for the UNS, right? So actually what we see is a lot of customers are spending a lot of money on AI, right? So they try to create AI projects do predictive analytics and so on. However, it's with everything, right? Shit in, shit out. If you do not put high quality data into AI, there won't be high quality outputs, right? So the AI is always limited to the availability and to data quality. And the unified namespace actually creates both, right? So if you do it right, the unified namespace, creates out of those data silos, creates that common namespace where you can consume data for your AI from your different systems, not only one PLC, not only one IT systems, but many and all in your landscape. And if you do it right, you also, and that's something I didn't touch today, you also make sure that you can consume standardized data. So I was jumping over the point modeling and harmonizing assets data, so harmonizing OT data, because most of the time OT data is not contextualized, it's not structured, it's not standardized in formats and so on. You cannot just push that into an AI and hope that it will make sense out of it, right? Not going to happen. So you need to make sure, especially in OT, that you model the data before it hits your AI and before you streamline the data through your AI. And that's exactly what you can do with iFlow. You can harmonize the data and then make sure that only harmonized and standardized data will be published into the common namespace. And from there, you can consume, with your AI, high available, but also high quality data to make sure that all your AI initiatives actually are successful at the end.
Right. Thank you, Daniel. The second one I selected here is extremely common to listen this during our conversations with the market. What's the process of implementing i-UNS in an already operating plant? It's extremely common to think that it's easier to implement, since I'm from the zero. If I'm building a new plant, it's easier to start with a new architecture. What's your comment about what's the journey of implementation to this company that's already operating? And if you see extremely different scenarios, if I'm doing on an ongoing plant or in a new ongoing plant, how do you see this? Because it's really common to listen, no, I'm operating this plant, I won't change anything. Maybe if I will build a new plant, I call to you. So what's your comment about that?
So actually the need rises the older your factories are, right? Because the older your factory, the more likely it is that your data is not available and the data is not in the quality you need it in terms of creating interoperability, or if you want to create AI on top of it, right? So actually the need for unified namespace, or for concepts like the unified namespace, increases with your brownfield scenario, right? So now making a greenfield case. So now if you want to create and plan a new factory somewhere, make sure that you already create standardized data from your system. So I always say, if you buy a new machine, make sure that the interface the machine provides is already standardized, right? And it's not standardized when you write OPC or MQTT into the spec. You need to go beyond that, right? So you need to specify how the data is structured, what's the data format, and so on and so forth. So basically, you want to make sure that the interface of your machines or IT systems, whatever you place in the new factory, are standardized and are specified enough to create that common ground. Most of the time, you won't have that in your brownfield factories. And that's where the unified namespace actually is very strong, right? And now, if we have a look into the brownfield factories, and if you choose a unified namespace or a vendor that allows you to create those architectures, make sure that it supports your protocols and it supports your systems that you operate in the brownfield factory. So making an example, the older your factory gets, right, the more proprietary the interfaces will get from your systems. So make sure you analyze the different protocols and the different systems, what interfaces they provide, and make sure that the vendor you select supports those protocols and those interfaces. I make examples in OT, speaking in OT, for example, that the system can talk to your Siemens PLCs, that the systems can talk to your Allen Bradley PLCs, or in IT speaking, the system can talk to your SAP.
Great, thank you again, Daniel. What's your message to an industrial director or a CEO of a company that the CIO is blocking some initiatives like that? But if you have an opportunity to talk with executive leadership about, okay, your technical guy is blocking me, but in the long term, your business benefit would be. What's your answer to that?
Yeah, so the higher you go up the ladder, right? So the more economical the discussions will get, right? So the question will become, what's the return of invest, essentially? And obviously the unified namespace is a middleware, right? So it's placed in the middle to do things on top, right? And that's also the tricky part of calculating the return of invest. However, you always have to look into the end-to-end use case. So I make a specific example, like the customer I showed you actually proved the value of the unified namespace, showing and proving that the data inefficiencies and the control inefficiencies from the legacy stack have been improved so much that they can increase the line output by X. So they have showed that end-to-end use case to their higher level management and convinced them by that to invest into a solid data foundation that can not only be the foundation for your control use cases, but also for all digital initiatives in the future, right? But making that very clear based on a specific use case is always helping to convince the higher management.
I think you already answered one of the last questions that I have here about how do you see i-UNS supporting downtime reduction or improving the operational efficiency. I think this case you mentioned is directly correlated with that, right? Improving the output of the line and doing more production because you implemented the UNS, right? And I think during your presentation you showed about maintenance, and it's extremely connected with downtime reduction too, right?
Yes, exactly. So that's also a very common use case to start with, right? So once customers start with unified namespace, they will not start with the most complex one. So connecting SAP sometimes is a little bit tricky because you need the right people in your enterprise to connect to SAP and so on and so forth. So that's why most of the people, they start with simpler use cases that they have actually the control in, and like, analyzing OEE, doing some dashboards to reducing downtimes, for example, condition monitoring, process monitoring is a simple way to start. And then proving the unified namespace and the data foundation piece by creating those more simple use cases is a very common way to start.
And my last one, because I think it's in the end of the day for you in Germany, I will be fast here. The last one is What's the common mistakes companies are making in this integration process using UNS? Let me try to rephrase. What are the best practices that you suggest to avoid mistakes and problems in this journey? So I think it's a good question to conclude here.
Yeah, so there are so many mistakes you can make, right? Most of them are related to your organization. They're not related to the technical part, but to the organization, right? So if you do not have a data culture inside your organization where people recognize the fact that you need a solid data foundation to create transform digitally, right? If people in your organization do not recognize that, the unified namespace will fail, right? So you need a data culture first, and you need the people in place that hold the budget and that recognize the need for those data foundations. And you need to make sure that you convince those people, to convince the right people. So that is first and foremost. There are some technical parts where it can get tricky as well. For example, I mentioned the data harmonization part, right? If you publish the data mesh from your OT just into the common namespace, you will fail as well, right? Because what will happen, you will just create a data mess inside one place, and you cannot consume the data out of it because it's messy, and you have to, individually integrate again. So you're again back in the days of the point-to-point integration. So that is also a very common mistake that we see. Publishing data mess into that unified namespace, don't do that, right? And again, so there are like a lot of more, but those are, two examples of organization and also technical part.
I completely agree. I think cultural problems, I think they are 75% of the journey, right? But
yes, so true.
But I will finish here, Daniel. Thanks a lot for your time, for your effort, for all the energy that you put in your presentation. Was extremely good. I think your strategic approach, dividing the steps in our control strategy evolution, it's really good to think in this direction with this dynamic, because it simplified the discussion internally in a company. So thanks again, Daniel. We are always available to you, to iFlow, to keep promoting iFlow here in Brazil. We appreciate your time. Thanks again. And that's it. Anything you need for us, just call.
Perfect. Thank you, Heitor. Also, big shout out. Thank you, Heitor and Marcos, for having me again on this webinar and masterclass. Thanks, and always happy to work with you.
Thank you, Daniel. Marcos, agora com você.
Maravilha. Thanks so much, Daniel. Obrigado, pessoal, todos que acompanharam aí. Quem não quiser depois reassistir, tiver alguma dúvida, essa live vai ficar disponível lá no nosso canal no YouTube. E também lá tem todas as informações, vocês podem entrar em contato com a gente e saber mais sobre essa tecnologia fantástica aí. Obrigado a todos que puderam acompanhar aí e até a próxima. Valeu, um abraço.